Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides additional practice distinguishing between the different levels of measurement for statistical data. Remember, you need to participate and actually give a response when I pause in the video if you want to maximize your learning. And in this video, we're going to continue the game we were playing previously. But if you were using that review table from the mini lecture or notes made from that table, I'm going to ask that you put that away for this video. Those are training wheels, and now it's time for you to get used to riding with them off. It'll feel a little wobbly at first, but only in this way can you get a real feel for the bike and ride like a king, or queen, as the case may be. Okay, with that introduction, here's our first example. U.S. News and World Report periodically provides its rankings of national universities, and in a recent year, the ranks for Princeton, Harvard, and Yale were listed as 1, 2, and 3, respectively. What level of measurement do we have here? I'll give you a moment to make your reply. Well, this is ordinal. The rankings are numbers, yes, but because they are used as categories, we have here categorical data. That means these data are either nominal or ordinal. Now, what's the difference between nominal and ordinal data? Nominal data categories have no natural order, whereas ordinal data categories do. Rankings are numerical and so have a natural order. Thus, these data are ordinal data. Here's the next one. For the 2016 presidential election, ABC News conducted an exit poll in which voters were asked to identify the political party for which they are registered. What do we have here? Yes, nominal. Names of political parties are by definition categorical data, which means we have either nominal or ordinal data. What's the difference? Nominal data categories have no natural order, while ordinal data categories do. Names have no natural order, and so here we have nominal data. What about the weights of chocolate ice cream cones served in Martha's ice cream shop? I'll dream of heavenly bliss while you make your answer. Okay, this is ratio. Our data are weights, which are definitely quantitative data. That means we have either the interval or ratio level of measurement. But which of these two is it? Interval data have no natural 0 point, but ratio data do. A zero data value here means you're weightless, that you have no weight. So we do have a natural 0 point, and that means we have ratio data. Next at bat, we have a study of fast food service times in which the time intervals of drive-up customers, beginning when they place their order and ending when they receive their order, are recorded. Well, again, this is ratio. Our data are times, which are definitely quantitative data. That means we have either the interval or ratio level of measurement. But which is it? We have a natural 0 point, and so that means we have ratio data. Here we have baseball statistician Bill James recording the years in which the Baseball World Series was won by a team from the National League. Now, you make the call. Well, this is interval. Years are the classic example of interval data, which have no natural 0 point, but a natural order among data values that have meaningful differences between them. How about this one? A randomly selected moviegoer rated the movie Star Wars: The Force Awakens with 5 out of 5 stars. Okay, this is ordinal. Remember, movie ratings may be numbers, but they're categorical data because those numbers are used as names or labels for different categories. Since there is a natural order for sorting data values, here we have the ordinal level of measurement. And we also need a 2x4 to wallop this random moviegoer's head, because Jar Jar Binks is the most obnoxious character ever created. Ever! I mean, seriously, every time I watch this movie, I can't help but chant, "Death to Jar Jar Binks." That has to drop the movie rating for at least 2 stars, man. Okay, next up we have body temperatures in degrees Celsius from a random sample of 126 patients in a hospital. Well, this is interval. You should know after the last 2 mini lecture videos that temperature data from either the Fahrenheit or Celsius scales have the interval level of measurement. They're quantitative data that have no natural 0 point, but do have meaningful differences between data values. Okay, here we have the defensive players of the Seattle Seahawks during the first play of Super Bowl. Oh my gosh, I hate these Roman numerals. God for the Arabs, right? I mean, they're the ones that gave us the numbers that actually make more sense. Okay, so let's see. The X is 10 and the L is 50, but the X comes before, so let me just subtract it out. So that's 40, the V is 5, and then plus the 3 makes 8. So 48, Super Bowl 48. Wearing jerseys numbered as you see here on the screen. What level of measurement do we have here? Well, this is nominal. When numbers are used as unique identifiers, they become names, which makes them categorical data. And since there is a natural ordering schema for these categorical data, we have the nominal level of measurement. And now last but certainly not least, the number of Beatles albums sold each year is recorded and averaged. Well, this is ratio. The numbers of albums sold are definitely quantitative data. We have a natural 0 point. I mean, 0 albums sold means you're not bringing in any money. And the differences between data values are meaningful. That makes this the ratio level of measurement. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.